Welcome to my channel, guys. Today we are going to do a few sums of linear inequations in one variable. We're going to do a sums that pattern of sums that look very difficult, but they're very easy. Okay, so let's take a sum: x minus 3 divided by x plus 1 less than 0. X belongs to R. So we have to find out what values x can assume so that this entire fraction is less than 0. Okay, now some students, what they would do is that they will multiply x minus x plus 1. They will cross multiply, right? And so you get less than 0. That means x is less than 3. Now this is a wrong method. Why? Because you don't know if x plus 1, this x plus 1 is positive or negative. If x plus 1 is negative, if you are multiplying the LHS and RHS of a linear inequation with a negative number, if you're multiplying or dividing the LHS and RHS of a linear inequation with a negative number, then this sign will change. I can very easily prove it. If I have minus 3 more than minus 5 and I multiply both sides, I say multiplying both sides with say minus 1, which is a negative number. So if I multiply this, then minus 3 times minus 1 more than minus 5 times minus 1. Okay, so what this would mean is that, so this will become 3 more than 5. This is wrong, right? So, and this is not true. So to correct this, what I have to actually do is that I have to change this sign. So whenever you are multiplying or dividing a linear equation with a negative number, the sign will change. So this will become this. Now it is correct, right? So you cannot directly cross multiply. In linear equations, you cannot directly cross multiply because you don't know if this is a positive or a negative number. Okay, so please remember that. Now, so now that you've understood this, now we will solve the question. Okay, let's solve it. I'm taking a new slide altogether. Okay. So our sum was what? X minus 3 by x plus 1 less than 0. Okay, so what you do is that you say, so what you do, I am multiplying the numerator and denominator with x minus x plus 1. So if I have 5 by 6, say I have 5 by 6 and I multiply both this with 7. Okay, so I can do this. This is equals to 5 by 6. I'll get the same result. So the same thing I'm going to do over here. What I'm going to do is that I see, don't confuse yourself. I'm not multiplying this LHS side with something or with RHS. I'm just multiplying this fraction. So let's say I multiply the x plus 1, so divided by x plus 1, x plus 1 less than 0. See, if I can actually cancel this and I'll get back the same thing, right? So I'm not doing that. Okay, so I multiply both numerator and denominator. Let me write it for you. Multiplying both numerator and denominator of LHS with x plus 1. Okay, that I can do. Now, then what will happen? It will become x minus 3 multiplied by x plus 1 by x plus 1 whole square less than 0. Correct? Right? Okay. So, now what will this equation become? So, I am continuing this over here. Now this will be x minus 3 x plus 1 by x plus 1 whole square less than 0, because this will become whole square, so that's the same thing. Now we already know that square of any number is positive. If I have 2 square, it's 4. If I have minus 2 square, it's also 4. So this is a positive number. Now I am sure that the denominator is a positive number, so I can cross multiply this and this sign will not change. Okay, because this, I know x plus 1 whole square is a positive number, so I can cross multiply this and this sign will not change because I'm multiplying or dividing with a positive number. So if I am multiplying this, if I'm cross multiplying this with 0, and I know it's a positive number only, so that I can do. Okay, so what will that mean? That will mean x minus 3 x plus 1 less than 0. Okay, now this how we'll solve, let me show you. So we got x minus 3, x plus 1 less than 0. I have to find out what values x can assume, so this entire thing is less than 0. So now what you first find out is the zeros of this uh the zeros of this whole thing. So the zeros is very easy. The zeros are what? 3 and minus 1, right? Because if I put minus 1 here, if I put in place x minus 1, then this whole thing will become 0. If I put 3 in place of x, the whole thing will become 0. What you need to do is that you have to find out the zeros of this LHS. So if I find out the zeros, now what will I do? I will draw a number line. I will plot minus 1 over here, 3 over here, and then I'll do this. Okay. Now see, now here is where the trick comes. Look carefully. If I multiply x with x, what will I get? X squared. And what is the sign before x? It's a positive sign. Okay. So because this is a positive sign, I will write positive, negative, positive. Now listen to this very carefully. Now, let us assume, now if suppose this had been minus x minus 3 multiplied by x plus 1. Now, if I had multiplied this and this, I would have got minus x square. So, the sign before x square, we are concerned with the sign before x square would have been negative. Then you would have written negative, positive, negative. But that is not the case. The thing is that x before x, the value is a positive. So if I multiply x and x, I'll get x square, which is positive, right? There is no negative sign. So because it's positive, I'll write positive here, negative here, positive here. Okay. Now I have to find, now what I will do is that, so now see, this value has to be less than 0. So any value that is less than 0 is negative. So which means that x will assume this range of values. X can only be inside this part. Okay. So which means what? X belongs to minus 1 comma 3. That's your answer. Okay. So the answer is not, sorry, the answer is x belongs to minus 1 to 3. Now here I have made an open bracket and here a close bracket. Why? Because see, our original equation was what? X minus 3 by x plus 1 less than 0. If I put the value minus 1 in place of this, then what will happen? The denominator will become 0, so the whole thing will be undefined. But I can put the value as 3 because it's in the numerator. 3 minus 3 is 0, right? And if I put this 3 minus 3, this will become 0. Okay. Now the value has to be less than 0. So since the value has to be less than 0, then we cannot assume 3 also. Had this been less than equals to 0, then 3 would have been there. Don't worry, we are going to do one more sum to get this concept clear. Let's do another sum. So let us take x minus 7 by x minus 2 greater than equal to 0. Again, the same thing I'm going to do. Multiply this less than equals to 0. It's the same thing. So this becomes x minus 2 whole square. I can multiply this because I know this is a positive number. So what I get? X minus 7, x minus 2 greater than equals to 0. What I had got? X minus 1, x minus 2 greater than equal to 0. I draw the number line. I plot the zeros. So the zeros are what? 2 and 7. So I plot 2, I plot 7. I make this wavy curve thing now. X multiplied by x. If I multiply them, I'll get x square. What is the sign before x square? It's a positive sign. So that means I'll write positive first, then negative, then positive. I have to find out the value. This value has to be more than equal to 0. So when it has to be more than equal to 0, it has to be what? A positive value. So hence that means x belongs to, now look here, this was the original question. Now in the denominator we have x minus 2. So the value of x cannot be 2. If the value of x is 2, then this becomes undefined. So we will not include 2. but we will include now this is negative infinity, this is infinity, I hope you know this. So the values of x are what they can be is negative infinity comma 2 union 7 comma infinity. Now why did I put in close bracket over here? Because x can assume the value of 7. If x assumes 7, see, if I put x as 7, then what will I get? I'm putting x is equals to 7, then I'll get 0 by 5 less than equals to 0. So 0 by 5 is 0 only. So yes, this is true, because this whole thing can be equals to 0. So that so this thing can be equal to 0, no problem. So this I can write. So this is why I have put an open bracket. This bracket, please remember, this bracket, if I write 5 comma 6 like this means that 5 is included but 6 is not included. This is an open bracket, right? And always before and after infinity you put if you have negative infinite, positive infinite, we always put this bracket. Why? Because we can never reach infinity, and so infinity will never be included. So that is why we have if you have plus infinity minus infinity, you put close bracket, sorry, open bracket. Close, this is close bracket, this is open bracket. Open bracket means we're not considering 6. We cannot consider 2 because because why? Because in the denominator we have 2. If we consider 2, this whole thing will become undefined. We can consider 7, because if I put 7 over here, I'll get 0 by 5, 0 by 5, and that is equals to 0. Anything 0 by any value, q is any value which is not equals to 0, this is 0 only. Let's do one more sum to get this concept clear. Okay, so let's take this sum. X plus 7 divided by, let's say, 2 minus x more than equals to 0. So now I can write x plus 7 divided by 2 minus x into, I can write 2 minus x by 2 minus x less than equals to 0. I can write this now, which means I can write x plus 7 2 minus x by 2 minus x whole square more than equals to 0, right? So now so now what will happen is that I can multiply this value with this without changing the sign. So that's what I'm going to do. What was this? Oh yeah, x plus 7 2 minus x more than equals to 0. What did I do? I just multiplied this with this, so it ultimately became 0. So I got this equation, x plus 7, this, I got this equation. Okay, now again, find out the zeros. What are the zeros? Draw a number line. What is the 0? Minus 7 and 2. So write down minus 7 and 2. You don't have to do this, I just do it like that only, it looks nice. So now here, if I multiply this and this, what is the sign before x square? What is the sign? Is it negative or positive? It is minus x into x, so it's a negative sign. Now here, because before x square it's a negative sign, I'll start with negative, I'll write positive, then negative. My condition is that this has to be more than equal to 0, so this has to be positive. So because this has to be positive, the value of x can be only between minus 7 and 2. We can take minus 7, yes, but we will not include 2, because if I include 2, then what will happen? This denominator will become 0. So the answer will be what? X belongs to minus 7 comma 2. This will be close bracket, because 7 I will include, yes, I will not include 2. Why? Because if I include 2, then this denominator will become 0, and that cannot happen, right? Now please, one more thing that I want to say, had there not been an equal to sign, had there not been an equal to sign, if there had not been an equal to sign, then x could not have been minus 7 also. This also could not have happened, because if I put minus 7, then x will be equal to, then this thing will be equal to 0, and 0 is not more than 0, that's false. So then this would have also been an open bracket, but that is not the case, right? So that is why our answer is this. This is our final answer. We will do one last sum, one more sum to get this concept absolutely clear. Let's do one more sum. Just okay. Let's do this question. 2x minus 7 multiplied by 3 minus 5x more than 0. How will you do this? Again, first find out the 0. So what will be the 0 here? This is, I'm directly giving you a sum. So here the 0 is 7 by 2, and here the 0 is, what is the 0? 3 by 5, right? So you plot them. 3 by 5 will come over here, 7 by 2 will be over here. Okay. Now, the value, now see, if I multiply 2x with minus 5x, I get minus 10x. The x 10x square. The sign before x square is negative, so I start with negative, positive, negative. I am supposed to find out the value more than 0, so I'll only take this positive value. So that means x belongs to 3 by 5 comma 7 by 2. Now here notice I have put close bracket because x can assume any value. There is no denominator over here. There is no denominator here. This is a separate question. There is no denominator here. Everything is in the numerator. So the whole value of this can also be 0. This can also be 0. Had this been in the denominator, then we won't have considered 3 by 5, because then the denominator would have been 0.